Okay, right, up next we have Tony and Chris from Itty Bitty Apps. So one of the apps that they work on is an app called Reveal. Have you ever been in Xcode and you've got like a really thorny kind of UI bug where there's like some, I don't know, like a gap at the top of your table view or like something that's supposed to be on screen that's not, and then you remember there's that kind of weird app in Xcode where you can kind of explode out your view and turn it around and look at it, sometimes work out what's going on. Well, Reveal was doing that before it was cool. All right. So, Itty Bitty Apps, we've got Chris here, who is a senior iOS and macOS developer at Itty Bitty. He cares deeply about accessibility, user and developer experience, software testing, and performance. Tony, he's been developing on Apple's platforms for more than 20 years. So he leads the delivery of the Reveal app at Itty Bitty Apps. And they're going to be talking to us today about a really important topic on accessibility. So please welcome them along today.
All right. Good afternoon, everyone. Let me begin by acknowledging the Wurundjeri people, the traditional custodians of the land on which we meet today, and pay my respects to their elders past and present. We extend that respect to Aboriginal and Torres Strait Islander peoples here today. My name's Chris.
And I'm Tony.
We are the development team behind Reveal, which you all just heard about, a productivity tool for mobile developers in the Apple ecosystem. Reveal is used daily by thousands of developers, from single people working as indie developers through to developers working in teams of hundreds. Today, we're going to explore how we can build better apps for everyone by bridging the accessibility gap. We'll talk about some of the subtleties of UI accessibility, take a close look at a selection of freshly caught accessibility issues, and show off some new tools that we've helped to help you do the same. But first, a brief bit of moralizing to get us started. It's nothing personal, unless you want it to be. When considering accessibility, it helps to think of your apps not as having the single interface that you use, but as having many user interfaces. And in the same way that you wouldn't ship an app where a button was visually off screen or had a label that just said button, you shouldn't ship an app where the same or equivalent is true for any of the other user interfaces. But you know all this. But your users aren't you. So from the outside, all they see is a broken app, not how important accessibility is or isn't to you.
All right, all warmed up? Hope everyone's feeling sufficiently motivated to get through this. All right, so let's talk about the accessibility gap. When we use this expression, we're talking about the gap between having a passing familiarity with the accessibility APIs and being able to wield them effectively. Now, you're going to close that gap faster if you start by understanding that knowing the APIs only represents one part of that challenge. And that's where we're going to start today. So we're going to take a whirlwind tour of the accessibility APIs now to cover how subjective and challenging they can be to wield well. When I talk about accessibility on Apple's mobile platforms, I'm talking about some combination of the accessible user interfaces like VoiceOver and voice control, alongside the UI accessibility protocol that's defined in the UIKit framework. Now, this protocol gives us a lot for free, even more so now through Swift UI. But it's a bit of a tricky customer in that it doesn't hold our hand in the way that we've become used to with other APIs in Apple's frameworks. This is because almost all of UI Accessibility's public API service is an Objective-C category bolted onto the base foundation class type NSObject, like a beautiful barnacle. For the members of the crowd who only joined us after Swift, Swift was introduced, an Objective-C protocol, much like a Swift protocol, specifies what methods and properties a class should implement, whereas a category or an extension in Swift adds methods and properties to an existing type. So over in Swift UI land, where everything's value types, roses and rainbows, your Swift UI views vend an accessibility node, which is itself an NSObject. And we think that's purely so that that amazing little barnacle can attach itself. So far, so good? Great. Where things start to come unstuck is that UI accessibility is an informal protocol. And what this means is that conformance to any of its documented properties or methods is entirely optional. There's no contract. There's no rule of law, and the compiler is powerless to stop you from shooting yourself in the foot. You don't need to read all this, by the way, that's just first sample, but
Here's a good example. There's an expectation that any accessible element that has the adjustable trait also implements the methods accessibility increment and decrement. That's an expectation, but not a protocol-enforced requirement. Not because it isn't functionally required. It is. It won't work if you don't. But it's impossible to enforce it. So they just have to strongly suggest it. And anything that's strongly suggested is rarely accomplished consistently. So Swift UI doesn't even let you set the adjustable trait directly for this exact reason. In short, UI accessibility isn't going to tell you when you're holding it wrong. So hold it carefully. Now, this informality is part of the reason that it's so fraught building your own components, like buttons, sliders, and date pickers. You might miss a crucial implementation detail and not even know it until someone tells you after it's shipped. Now, you might make the assumption that because most UI components have accessibility built in, just by sheer virtue of being NS objects, using UI accessibility should largely be a matter of adjusting up from a decent baseline, right? Well, no. Sometimes what we get for free isn't what our users want or expect. And the issues here may be subtle and difficult to recognize. So trust, but verify. The best advice I can give you is to be mindful of how Apple uses UI accessibility and to let that inform your decisions. So how do Apple use it? To be reductive, for all their various assistive technologies. This is great for us as developers. And as I mentioned, in a lot of cases, we can adjust up from a good baseline and achieve reasonable results. In theory, this approach minimizes the amount of code that we need to write to cover our users' needs. But it's not without its drawbacks. Apple's assistive technologies have differing implementation requirements, but often use the same UI accessibility properties to fulfill them, implicitly making these requirements your responsibility. And remember, there's no hand-holding with UI accessibility. Take, for instance, the accessibility user input labels property. We still don't expect you to read all that. This property is a string array that's meant to be used when, and I quote, the label isn't appropriate for dictated or typed input. If the array is empty, it'll be populated by the accessibility label. If that's empty, it'll be the visual label of the view, if it has one. But crucially, if the array isn't empty, if you've set a value explicitly, it won't fall back to either of the two labels. And as far as I'm aware, this isn't documented anyway. Furthermore, and this may not be clear at first glance, there's a bit of tension in the requirements here. Voice control, Apple's method of controlling your devices using your voice, wants short, unique labels. The first of these labels is displayed on screen if you tell your device to show names with voice control active. Full keyboard access, which is another one of Apple's assistive technologies, has a pretty self-explanatory name, arguably wants whatever the visual label is, or a descriptive name in lieu of an icon. Sorry, in lieu of text, if there's an icon. This is because you won't see an overlay like voice controls when you search for items until you've got a partial match. So if there's absolutely no relation between what the input label is for an element and what the user expects it to be, they could have a hard time finding it. You could argue then that this array should always contain, in order of priority, short and unique labels, then the visual label, if available, or the accessibility label.
Okie doke. So perhaps it's an obvious thing to state, but Apple's assistive technologies are built with the users in mind, not with us as developers. And regardless of the technology in question, users will always use that technology in the way that works for them. Accessible needs are intersectional, so the combined space of user requirements around this quickly becomes staggering in size. It's our job to meet those needs where they actually are, not where we think they might be. What good accessibility looks like, it's going to vary from person to person and use case to use case. And like with software development in a broader sense, it can be easy to fall into the trap of inventing needs to satisfy or trying to preempt every potential situation. There often is no best solution, only acceptable compromises. So if we can draw any kind of conclusion from what Chris and I have just talked about, it's that context and consistency largely determine the quality of an accessible experience. The less that your users have to work to understand your interaction model, the better. The fewer mystery elements there are on your screens, the more intuitive your app will be. It all comes down to empowering your users to use your app in the way that works for them. All right, so Chris and I both work on Reveal, and we thought, surely there's something we can do to help you. But first, a little bit of background. Reveal's 10 years old this year. Reveal and I are both up for long service this year. It's a very mature app, and in fact, as it was mentioned earlier, it does predate Xcode's own View Debugger. We're very proud of how accurate it is and how long it's been going. Now, over the course of the last 10 years, Reveal has made an effort to show you what's going on in your app's viewer hierarchy, allowing you to quickly tweak values or accurately identify and fix layout issues. Last year, we launched our accessibility workspace, which was an entirely new feature set that quickly, clearly surfaces the accessible user interfaces of your app and provides additional features that allow you to see your app as your users do. Now, while both the layout and the accessibility workspaces provide a huge amount of useful detail, they largely leave it up to you as the developer to determine what all that detail means and what to do about it. On their own, the tools that we're shipping right now are not going to help us to bridge that accessibility gap that we've been talking about. Further, the accessible user interfaces of your app only exist at runtime, and that's the only context in which they can be tested properly. Reveal gathers and analyzes data about your app at runtime. So we put 2 and 2 together. We had a bit of an aha moment and a little flash of insight. Remember how we mentioned that learning the API was only half the challenge of bridging the accessibility gap? What if you could automatically verify the preferred order of our old friend accessibility user input labels? What if you could do the same for a whole range of potential issues that could affect your app's accessibility? Well, we built something to help with that, and we're calling it Reveal Insights. So what we'd like to do now is crack open a complex real-world app, have a look at how we can improve the accessibility of some of the examples within that perhaps aren't clear at first glance, or that look clear but have side effects or unintended consequences. And to do that, we're going to use an app called Ice Cubes. It's an open source Mastodon client developed by a fellow named Thomas Rickard. Now, Ice Cubes is a pure Swift UI app. It already supports landscape mode, it has dynamic type throughout, and its use of color is largely in line with the Apple Human Interface Guidelines. So it's in a good state to start with. And to be very clear, Thomas has given us his blessing to use Ice Cubes in this presentation today. And everything that we cover, we've made an effort to upstream into the Ice Cubes open source repository and into the product that he's shipping. So hold tight, give us a moment. We've just got to turn off screen mirroring to get this to go. So.
Yeah.
Bump you down to a reasonable resolution. Like that.
Is that too reasonable?
I don't know.
No, that's good.
How's that? Is this where we're starting? Take it away, Chris.
I believe so. So, you have an app, and you want to either make it accessible or improve its accessibility. Where do you start? Well, most apps have a couple of key flows where users spend most of their time. That's where I would start. And that's where we'll start with Ice Cubes. But first, let's do a quick little tour of Reveal so we can familiarize ourselves and have everyone on board here. So, on the left here, you can see the navigator. In voiceover mode, which we're in now, it contains a list of all the on-screen accessibility elements with an approximation of how they will be spoken by voiceover. In the center here, you see a canvas with the frames of these elements annotated. On the right-hand side are a series of inspectors that provide finer details about each element. Let's move over to the new Insights workspace. On the left, you have a navigator. In this workspace, it contains a list of rules. And we've created a smaller subset of the rules that we have available just for this technical demonstration, just, so we don't get lost in the weeds of the detail here. In the center, we have a long scroll view containing all the rules. And these rules represent one issue. They provide context for what the issue is, how to resolve it, and references. At the bottom, you'll also have a list of results, if available. And on the right-hand side here, we have another canvas showing you the viewport of your current screen. This is the timeline screen in IceCubes. This is where people spend most of their time, just basically reading whatever's the newest thing happening. Now, if we go over to the navigator again, we can see that the rule missing heading is telling us that this screen does not have any element with a header trait. And this is important. Having headers allows people using screen readers to quickly familiarize themselves with the overall structure of a screen. And for screens with very complex information hierarchies, these users are able to quickly move between different sections using the heading rotor. Now, if we go into the accessibility workspace and have a look at this button, we can see here that it does not have a heading trait. But crucially, there's something else. If we look here, we can see that to the right of the label itself, there's an icon that indicates that this is some kind of menu. But it's not interactive. Let's have a look and see what's wrong. So this is a toolbar item that contains a switch that has some business logic attached to it, but it is a text. And this is why it's showing up as just the static text element. To be able to tell people that this is a header and that it's interactive, we can simply add the trait header. Easy enough. But to really contextualize what it is that this button does, we have to use the SwiftUI accessibility representation modifier and change it to present as a pop-up button. What this does is it adds a private trait that will be read by the screen reader as pop-up button and give a contextual hint about what will happen. And what will happen when you press this button is that it will change focus. It'll show a pop-up button, a pop-up menu, and it'll change the voiceover focus to the first element in the menu. Now, this can be disconcerting for people to have their focus changed around, especially when they don't expect it. And we also add here at the bottom a Boolean that sets response to interaction to true. And this affects a different kind of assistive technology. If we now look at the results, we can see that missing heading now passes. And if we go to the accessibility workspace, we can see that it now has both the header and the pop-up button trait. And changing to voice control mode, we can see that this is now available to voice control, and by extension, also switch control and full keyboard access. Let's move on. Remember earlier when we said that what you get for free may not be what your users expect or what you really want? This is a very good example. In the rule SF symbol label in element label, we can see that it's telling us that all the buttons in this picker or segmented control have labels that are synthesized from the fallback label or the file name of an SF symbol. And if you look here, you can see that it's comment right, conversation, and photo.on rectangle.angled. Now this is, the first two of these are quite subtle because arguably they're almost correct. And this can be really hard to pick up in testing because to someone else testing it, like a QA person, the fact that it is a deliberate label and not a file name may not trigger the response that this is an inaccurate label. Let's have a look at how to fix this. Well, blissfully, this is an easy fix. You just add an explicit localized accessibility label. The hard part here is, well, remembering to do it every single time and or catching it if you don't. And let's have a look at the result here. Excellent. Now if we go into the accessibility workspace, we can see that it is now posts, posts and replies, and media. Let's move on. When we look at the rule tap target size element, I'm having a problem selecting here. We can see that it's telling us that 5 elements on screen fall below the size, the minimum size required by Apple's human interface guidelines. And if we look at image without description, we can see that it's telling us that there is an image here that does not have any kind of description. And these two failures aren't really two separate failures. They're just two expressions of a single larger failure, and that is one of consolidation or element grouping. And arguably, grouping accessibility elements correctly is one of the biggest quality of life improvements you can make for your users of assistive technologies. For voice control users, it's much easier to build a mental map of what your UI works like and looks like if there's fewer elements on it and they make sense. For users of switch control, it makes it much, much faster to navigate around. And some users of switch control have mobile difficulties or mobility difficulties to the point where it will cycle through each element and then they choose explicitly to action it. And when there's 5 elements instead of 1 and you have no context for what either of them do, it takes much more time. For voice control and full keyboard access, it just adds clutter and ambiguity because all of these items are interactive and they do the same thing. And let's have a look at why they do the same thing. So this is what the code looked like at a high level. You can see there's a content shape with a tap gesture recognizer attached to it. And what this does is it lets you tap anywhere. Any user interfacing with the app would be able to tap anywhere on the area of the H stack to trigger this tap gesture. But Swift UI will create as many accessibility elements as it can from the H stack, and it won't do anything to unify them in this sense. It will add the tap gesture recognizer to all of them and make them all interactive. What we could do is we could use the combination combination modifier again and just combine them. But what we'd have then is an interactive text element because it munges together all the traits and sort of tries to pick the ones that make sense, which, you know, what you get for free may not be always what you want. So you'd have to add the button trait. So it's a 2-line fix, which isn't too bad. To my mind, the ideal solution here is just to wrap it all in a button. And the end result there is arguably less code and an accessible representation that looks exactly like what you expect. So you can see it's a button, it has a select trait, and it's interactive. So checking color contrast well is arguably more involved than just taking 2 color values and inputting them into a contrast calculator somewhere on the internet. There are a lot of concerns. Like, for instance, what if you use multiple colors in a label? What if, for instance, like we can see here, there's link detection that will automatically color text? What if color intersects text, like when an image is, when text is placed on top of an image? There's a lot of situational things that can affect the contrast. The accessibility workspace has a contrast checker. You can see here that it's picking out instances of this accent color, which is links, This is also the accent color. And this is part of the app's own internal theming system. So it's okay. You could choose a different color if you wanted to, if you had low contrast color vision or other sight issues. Now, it's also picking up the use of secondary label, which is a system color from Apple. And arguably, at this size, it doesn't pass the WCAG AA contrast guidelines. But it supports the high contrast accessibility setting. And if you enable that, then the color that gets rendered passes. So there are a lot of concerns and things you need to take into account when you test for contrast. I would advise you to always enable high contrast, because it is possible, if you manage your colors through an asset catalog, to create own variants for high contrast mode. And because checking for contrast is quite slow, in Insights, we've added the ability to automatically run contrast checks on your screen against both the Web Content Accessibility Guidelines AA and AAA, as well as the new APCA contrast algorithm, which is being evaluated for WCAG 3. It addresses a lot of the shortcomings of the current contrast algorithm, but WCAG 3 is a long way out, so I would stick with 2.1 if you have that as a requirement. You can also run each of these contrast checks against a color vision deficiency. So if you have colors that work for users with normal color vision, but don't work for people with, say, difficulty discriminating between reds and greens, you can now easily test for that as well. And that's all we have to show you. Let's have some more presentation.
So I hope that demo gave you a few practical examples that you might be able to apply to your own apps. Things like the combinations that Chris showed you. Checking color contrast is obviously a very big one for a lot of users. I also hope that it clarifies that bridging that accessibility gap and going beyond just the basics will have a real-world meaningful benefit for users of your app who make use of these assistive technologies. I don't want to spend too much more time on Insights today, except to say that we currently have more than 100 rules out of the box that work on both accessibility and layout data. The rules cover everything from the big, does my app support landscape mode, right through to the little, did I forget to set the translate auto resizing mask into constraints boolean, which we always forget, and were developed in cooperation with experts in our community. Now, what we just saw in the demo looked amazing, right? So you're going to run that up, it's going to show everything that's wrong with your app, and you're thinking, quick, let me have it. We'll go home and use that instead of whatever about the manual processes we've been using to check those things. No. Let's get this out of the way up front. There's no substitution for manual testing when it comes to accessibility, especially testing performed by native users of assistive technologies. At the same time, we often see that the two forms of testing are portrayed as being somehow in opposition. The truth is that they're complementary. We need both, and we should be doing both. Providing the level of context and consistency required to ship a great accessible experience can be difficult and time-consuming. So anything that makes this process easier makes it more likely to happen. Automated tests can catch regressions in things that may not be front of mind on any given day. All right, so wrapping up, I'd like to briefly touch on what it means for something to be accessible. It's not just about extreme cases. It's not always about people interacting through brain-computer interfaces or eye tracking. It's about trying to read your screen in the full glare of the sun. It's being stuck in a bumpy car ride, desperately trying to tap out a message while your phone's shake to undo functions, but doing its best to stop you. That one's a true story. It's about using the triple tap on the back of your device to switch between apps because you broke your finger cleaning the chain on a powered cargo bike. Also a true story. It's about all of us. And it's about empowering your users to use your app in the way that works for them. Okay. Thank you so much for your time today. We hope that you've enjoyed our talk. I don't want to belabor, it's not a product announcement, but if you are interested in using Reveal and you're not already, you can send an email to the address on screen and we'll send you out an extended 2-month trial and let you know when Insights launches, which is not far away. If you would like to help us with Insights and join the beta, same deal. shoot an email there or come and find Chris and I during the conference and have a chat to us and let us know. That's all from us, so thank you very much.